Alrighty, you guys all set to tackle this together? Alright. So, again, the front side I think is pretty straightforward. If you can do the first one, you can probably do the rest. The main thing there is making sure that your calculator is set to degree mode. If it's in radian mode from a math class, you're going to get different numbers when you do those sine and cosine things. So, backside. Number 5, we already talked a little bit about the force diagram and the force equations. So we'll just kind of start there. We've got gravity going down. There's a tension force. There is a normal force, and there is friction. And it's static friction because the box is not moving anywhere. Now again, like you guys mentioned, our normal force is smaller here because we are pulling up on that table, and that means the ground has to exert less effort, less force, in order to keep it from falling through. So that's why normal force is smaller in this case. So we've got a little 30-degree angle here. And because that tension force is not acting exactly horizontally or exactly vertically, we have to break it up into its x and y components. And that's kind of step 1 here. So this would be our tension in the x direction. This would be our tension in the y direction. And that's our setup. And again, for those force equations, we're just writing them from all the forces going one way, and then we're subtracting all the forces going the opposite way. So horizontally, my force equation is simply tension in the x direction minus forces static friction equals 0. Because I'm taking all the forces going to the right minus all the forces going to the left. And vertically, it's all the forces up minus all the forces down. So that means normal force plus tension in the y direction minus gravity equals 0. So those are our 2 force equations. Questions so far? Okay. So then the next part, letter C, says determine the x and y components of the tension force. So now I'm looking for that and that. And I can figure those out because it tells me exactly what the tension force is. The tension force is 200 newtons. So that's my hypotenuse. Now if I'm looking for the adjacent side, FTX, is that cosine or sine?
Cosine.
Cosine, exactly. So cosine of 30 is equal to adjacent, which is FTX, over hypotenuse, which is 200. So to get the tension force by itself, we multiply both sides by 200, and you can get your answer that way. If your calculator is properly in degree mode, this will end up being 173. Yes.
You want us to round always?
I usually round to 3 digits. If you want to go further, that's okay. But in the answer keys online and stuff, I round to 3 digits. In the y direction, this is the opposite side, so that means we got to use sine. So it would be sine of 30 is equal to FTY over 200. And then we get a similar expression to this. So when you do that math, you'll end up with 100 on the dot. Questions up to this point? Guys, you're going to have to wrap it up back there. Everybody okay with this? Okay. So then Letter D says find the force of static friction and also find the normal force. So if that's something we want to do, when you're looking to calculate these numbers, you do not look for a specific equation from your formula sheet. What you always do for these problems is you go back to the force equation that you wrote and you try and solve for it that way. So if I want to figure out my force of static friction, all I got to do is isolate it in my force equation up here. So if I want to isolate it, I would just toss it to the other side then. And Ftx is equal to force of static friction. In other words, if I can find this, I automatically know my force of static friction. And we just calculated that. That was 173. Now the other part that it's asking for is the normal force. And this is the exact same procedure. Normal force is here in this equation. So this is where I'm looking to try and solve for normal force. I'm not looking on the equation sheet for an equation for it. I'm looking at my force equation. And I'm going to take that normal force and just solve for it. So when I do that, force of gravity moves to the other side, and it becomes positive because it was negative over here. Tension in the y direction goes to the other side, and that becomes negative because it was positive over there. So this is the expression you end up with. And we can plug those numbers in. Gravity in the y direction. Tension in the y direction. Tension in the y direction we calculated from the previous part. That's 100. Anybody remember how to find force of gravity? Yes.
9.8 times 50.
Yep. Mass times 9.8. And in this case, our mass is 50 kilograms. So it's going to be 50 times 9.8, which gets us a number. I didn't write that number down. But if you take this number and then you subtract 100, you'll get your normal force, and that's 390.
We did what? Are you supposed to subtract? Oh no.
Questions, concerns? So that's number 5. Number 6 is pretty similar. So this one will go pretty quick. You guys sure you're okay with this? Okay. Because this is really important. We're taking this another step tomorrow. Number 6 is similar, except now, instead of pulling up, we're pushing down at a 30-degree angle. So if we're pushing down at a 30-degree angle, we've got gravity. It's still acting down. We've got normal force. Is normal force going to be bigger or smaller than gravity here? Bigger, because we're pushing down on that object. And if we're pushing down, that ground has to do more force to keep it up. So our normal force is bigger than gravity in this case. And because we're pushing down and to the left, it looks like, that applied force is headed in this direction. And that's at that same 30-degree angle. And it appears that the desk still does not move. So that means we've still got friction. And because friction always goes in the direction opposite the motion, friction's going to be pointing to the right. Because if it wasn't there, it would move to the left. So friction is pointing straight right here. Force of static friction. And that's the start of our force diagram. In order to finish it up, though, remember applied force is headed in both the x and y direction, so we have to break it up into its components like we've done already in the past. So this would be my applied force in the x direction, and this would be my applied force in the y direction. It's going to the left and it's going down. So, letter A, write the equation for the forces acting in the x direction. Well, we've got applied force going one way, we've got friction going the opposite way, and so our equation is just going to be applied force in the x direction minus friction equals nothing. Vertically, we've got three forces. We've only got one going up. We've got normal force going up. So we'll start with that. Going down, though, we've got both the applied force in the y direction and gravity. So those two are both headed downwards. Yep. So that's what our force equation vertically is going to be. Questions up to this point? All right. So let's finish this off. Letter C says, determine the value of the force of static friction. Do the same for the normal force. So once again, if I want to find my force of static friction, I do not look on my formula sheet. I look at my force equation that I just wrote down. Force of static friction is going to be equal to the applied force in the x direction, just like it was equal to tension in the x direction in the previous example. You just toss this over there, and they're both equal to each other. So I just got to solve for the applied force in the x direction. So that is the adjacent side. Because it's the adjacent side, I got to use cosine. And I'm just going to take a little shortcut here. By now you're probably tired of me doing the sine and cosine thing with like 3 steps. Basically, you can summarize it like this. It's going to be the applied force, which is still 200, times the cosine of the angle. And that's going to be equal to 173 again. So that's your force of static friction. The other step would just be, it's the adjacent side. So cosine of 30 is equal to adjacent over hypotenuse. Hypotenuse is 200, just like the last example. And then you get to this point. And finally, vertically, we got to find normal force. And we can figure that out because we just got to look at the equation we created with normal force in it. And we got to get that normal force all by itself. So that's pretty easy to do. Normal force will stay over here. These two things get moved to the other side. So normal force will be equal to the combination of them. Applied force in the y direction plus force of gravity. So applied force in the y direction is going to be the same equation as this, except you're going to have sine. (200) times the sine of 30 will get you the applied in the y direction. Force of gravity, again, is just mass times 9.8. We haven't changed the mass. It's just 50 kilograms. And we multiply that by 9.8. So, add those two products together, and out pops your happy normal force, and that's equal to 590. And that's all she wrote. Your homework for tomorrow is to take worksheet number 2 and study it. Make sure you know how it all works, because we'll be continuing on with this stuff tomorrow.